Hello and welcome to our next unit, Rationals, that we will begin today. First of all, I want to say congratulations. You did complete an entire unit on your own, now from beginning to end, the radical units on your own during remote learning. Remember, on your own means you're at home, but on your own doesn't mean that you can't email me and check in. If you need help or want things worked out, let me know. So you're not on your own, you're just at home learning on your own. Thank you for the feedback. I sent out an email to all of you the other day, so it's good to get that feedback, and I do adjust and change things based on I hear what your strengths and challenges are. So keep up the good work. I know it's a quite different experience for all of us, but I just want to congratulate all of you. Congratulations for completing Radicals unit on your own. Now we're doing the rational unit. We're going to start simply. I'm breaking the lessons up to small parts. The notes that I've emailed you, I may not do all the examples on there. We are just looking for the key concepts right now. There are some things in grade 11 that you do need to know to go on in grade 12 and beyond in university. And since it's pre-calculus, I'm assuming you will be taking calculus. So I have to look not just ahead to next year, but the next couple years. So there's a few things we definitely have to still cover in this remote learning time. I have taken away the mental math. I know you'll be sad about that, but hopefully you've built up your strong skills already in that 2 months we had together. I've taken away word problems. I know you're very sad about that. So I've just kind of reduced the amount of content and the extras. And in the notes, I just want to teach you the core essentials that you'll need, and I'm shortening the assignments as well. So I hope that's been helping. And like I said, it sounds like most of you are doing quite well with this new experience. So congratulations for that. Okay, welcome to Unit 5, Rationals. So today's lesson will be quite simple. Again, there's nothing new at all in this unit. We're just using skills you have learned in previous years. So if you've done your homework in the last couple years from kindergarten to grade 10, this should be an easy unit for now. It involves factoring and fraction work. So skills that you should be coming in strong in those skills. Okay, so today we're just going to look at a non-permissible value. So before we begin that, we're going to just remind you what a rational number is. We did learn this back in grade 10 when we classified numbers. So we know from grade 10, a rational number is a number that can be expressed in the form of a over b, and b cannot be equal to 0. So that's a fancy way of saying a rational number is just a fraction. So yes, we are back to fraction work, which you've learned how to do your fractions back in grade 7 and 8 math. So if you can add, subtract, multiply, divide fractions, this is easy for you. We did do that work on our mental math prior to this suspension. So like I said, if you aren't strong in that, you've got lots of time to brush up on your fraction work. So if you've done your fraction homework from grade 7 and 8, this unit should be quite simple for you. Okay, so rational numbers are fractions, so we're basically dealing with fractions this unit. And remember, because we have fractions, we have a denominator, and we said you cannot divide by 0. So anything that makes the denominator 0 is not allowed. So if it's not allowed, we say it's non-permissible. So all we're going to do today is look at the fraction and just think what number would make that denominator 0, and whatever that number is, we say it's non-permissible. It's not allowed because you can't divide by 0. That's all we're doing in today's lesson, so it shouldn't be that bad. Okay, so let's give it a try. We'll try a few examples together. So the first one, I don't know if you can see this in the video. Let's see how this goes. First example, 3 divided by x. This is a pretty simple one. X cannot equal 0. That one we get the answer just by looking at it. We don't have to do anything. You can't divide by 0, so anything that makes the denominator 0 is not allowed, so x can't equal 0. Okay, that was pretty easy. Let's try a harder one. Example 2, 2 divided by y plus 1. Maybe some of you can look at the answer and get it right away. If you can, y cannot equal negative 1. Negative 1 plus 1 is 0, so it's not allowed. If you can't see it, then we'll do like what we did when we were solving quadratic equations. If you can't see the answer right away, set the denominator to 0, and then you rearrange and solve. So that's the number that makes the denominator 0. But because it's a non-permissible, we have to use the not equals to. So y cannot be equal to negative 1. Again, you don't have to show the work. If you can see the answer, you can go straight to the answer right away. But if you couldn't, that's the work you would use to solve for it. Okay, let's try a couple more. Example 3, x plus 1 divided by p minus 5. Now, the non-permissible only comes from the denominator. The numerator can be 0. That's fine. You can have a 0 on top, but you cannot divide. So we don't have to worry about the x plus 1. There's no non-permissibles there, just the denominator. So rearranging, p cannot equal 5. Again, you don't need to show the work. If you can see that right away, I see there's a bit of a glare, but you can follow along in your notes, hopefully. Okay, our fourth example, z divided by 2x minus 3. Again, we have a variable in the numerator, but we don't care. Not that we don't care, but the numerator can be anything, that's fine. The only issue is the denominator. You cannot divide by 0. So what value of x makes the denominator equals to 0? Again, if you've been doing your quadratic equation work, we've done a lot of work about setting things and solving to 0. So for this example, x cannot equal to 3 over 2. You don't need to convert to decimal. It's fine to leave it like that. Again, the numerator is fine. We're just concerned with the denominator. Okay, we have a couple more to try. I think we're getting the hang of it, but oh, okay, this is a fun one. 3 divided by 5abc. Now again, this is a monomial. This is 5 times a times b times c. So when you're multiplying, that's one term. So if a was 0, the whole thing would be equal to 0, so a can't be 0. But b also can't be 0, and then c also can't be 0. 5abc is a monomial, so neither a nor b nor c could be equal to 0. We just have one more example really to look at that we haven't covered, because we've kind of covered every kind of non-permissible that can come up. 2y over x squared plus 2x minus 15. Okay, again, the numerator we're not concerned with, the denominator we are. That's a little hard to tell right away what the non-permissibles are. So first step would be to factor. Like I said, factoring does not go away. You'll be factoring a lot grade 11, grade 12. We spent a month last year in grade 10 learning how to factor, so I'm assuming you know how to do all those types of factoring. We did review, we've done mental math, I gave you a practice sheet, so it does not go away. So you need to be able to factor quite quickly and efficiently to continue on in grade 11, grade 12, and in calculus. That's an easy one. A is 1. I think we're pretty good at that. So now we look at it, there's 2 spots. So x cannot equal negative 5. Oh, the pen's not working. But it also can't equal 3. So you have to test both spots, and you would have 2 answers there. So we have one more example, but that's pretty much it. I've shown you 6 different types of non-permissibles. It doesn't really get that much harder than that. As long as you can factor and solve for the missing term, that should be pretty easy. Okay, example 7 is different. It says simplify. So again, step number 1, we have to factor. So grade 10 math, the numerator is removing a common factor. Grade 10 math, your denominator is a difference of squares. So like I said, there's absolutely nothing new we're doing anymore. So that's why we spent a long time in grade 10 factoring, so you could have a strong base. So when you hit grade 11 and grade 12, this step should be easy. Okay, so step 1 we factored. Now step 2, oh, we can cancel. So when we cancel, we have x cannot equal negative 2. But now here's the fun part. We still have to state our non-permissibles. Where does the non-permissible come from? The original or the factored form or the simplified form? You do have to take it back from this step here. This is where your non-permissibles. So even though you've canceled them out, you still have to put that there is a minus 2, because otherwise that would be a different equation. And this comes up a lot in grade 12 pre-cal, we're talking about non-permissible. So you can't, if you just put plus 2 and forgot that there was a minus 2 before you canceled, you would be losing some marks, because you're kind of missing the concept that there was another factor there before we simplified. Okay, so today's lesson, we're just going to simply practice, figure out non-permissibles and simplifying. And if we can do that, then our next lesson will be about adding, subtracting rationals, and then multiplying, dividing. Again, all we're doing is factoring, adding, subtracting, multiplying, dividing fractions. There's no new skills there. So if you're struggling with that, you've got lots of time to brush up on your fraction work and your factoring, and that will make this unit easier. Okay, good luck with the assignment.